delta L. Why am I leaving delta L there? Because you need to substitute for it. It's already here. What I need is just to introduce L in the denominator. But how do I introduce that L? From here, from this point, I want to make L the subject. Multiply through by G on both sides becomes T squared G, then over K squared. This is equal to L. T squared times G over K squared is L. But since what I'm having here is I'm having K squared in the numerator, then I have T squared G in the denominator. So this implies that if I'm to get the reciprocal of L, if I write 1 to go up and L to go down, this is also going to exchange. K squared goes up, then T squared G goes down. In other words, wherever I find K squared over T squared G, which is something like this, I'll put 1 over L. So I'll say that now delta T over T is equal to, I've said that K squared, I have silent there. Now I have K squared, which is this, then over GT squared. GT squared is the same as T squared G. Multiplication is commutative. 3 times 2 is the same as 2 times 3. So it doesn't matter what you start with. So K squared, I said wherever I find it, I substitute with the 1 over L. So this is 1 over L. But we have a delta L times delta L. Then I'll have delta T over T being equal to delta L over L, but there is a half somewhere. But they gave us delta L over L as 8%. So I come and substitute it here. This is delta T over T is equal to a half times 8%, which therefore becomes delta T over T is equal to a 4%. So that is the percentage error made in measuring the period of the simple pendulum. Thanks for watching. We meet in the next video.